Hello guys, welcome back to my YouTube channel. Today I am going to solve day 15 problem of this month on LeetCode. Before solving, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now, without any delay, let's get started with today's problem. So today we are going to solve problem number 238, that is product of all array except self. Okay, so in this problem we have given an integer array nums. Okay, and we have to return an array answer such that our answer I is equal to product of all the elements except our current nums of I, right? So here let me copy this example here. Okay, so here we need to find our output such that, like, for this particular position I have to ignore this element and I have to do the multiplication of all the elements. 2 into 3 is 6, 6 into 3, 6 into 4 is 24. So 24 is the output for my index 0. Same way for index 1, I have to multiply all the elements except the current index. Okay, so 1 into 3 into 4 is 12, so this is the my output. Okay, same way for this index 2, I have to multiply all the numbers except this number. 1 into 2, 2 into 4 is 8, so 8 is my output. And for this particular index, I have to multiply all the numbers in my nums except this particular number. So what is the output? 1 into 2 into 3, that is 6. Okay, so this is what we need to do. And the product of any prefix or suffix or number is granted to fit in 32-bit integer, and you must write an algorithm that runs in O of n time and without using the division operation. Okay, so here everyone can solve this question easily using brute force. Okay, so here this is the, let's say you are applying the brute force. Okay, so here what you are going to do, you are going to run one loop for all the elements, and after that you are going to run one more loop. Okay, nested loop, one loop inside another loop, right? And inside that, if you are checking here you are checking if my I is not equal to j. Okay, because we need to ignore the current element, right? And you are doing the multiplication of all the numbers except the same index, right? I is not equal to j, you are doing the multiplication. Okay, but here for this loop you are going to use O of n. Okay, and for this loop you are going to O of n. Okay, you are going to propagate your array 2 times, right? You are going over your array for the 2 times, right? So time complexity is going to be O of n square here in this case, and definitely you will get this TLE error, time limit exceeded. Okay, so we can't apply. So see here, you can see here 19 of 22 test cases passed. Okay, so when you are going to submit the code like this using brute force with time complexity of n square, your test cases will fail with this error, time limit exceeded. Okay, so this is not the best solution. Okay, so in order to solve this, what I am going to do here, so this is my nums array. Okay, 1 2 3 4, this is my nums array, and here I am going to get right here the left side products. Okay, and here I am going to write the right side products. So what is left side products and left side products? Okay, left side products and right side products. Okay, so here this is my array given to me, right? This is the array given to me. Okay, this is the array given to me, and this is index 0, this is index 1, this is index 2, this is index 3. Okay, this is clear. Now left side products. So initially, let's say the product at this index, I am going to check for the left side products of an element. So initially let's take this value as 1. Okay, and here in the right side products I am going to check the right side values products. Okay, so initially let's take this value as 1 here. Okay, so these two things that I am declaring first. The left side products of this particular index is 1, the right side products of this number is 1 only. Okay, because if I take it 0, then multiplication will become 0 only. Okay, so that is why I'm taking 1 as a base case. Okay, so now when I multiply, so what is the product of all the numbers in the left of this particular index 1? It's nothing but 1 only, right? All the numbers, what are the numbers before this particular index 1? Just 1. So what is the product? 1 only. Okay, what is the product of all the numbers in the left of this index 2? That is nothing but 2. Okay, so I have written 2 here. What is the product of all the numbers that are in left of this index 3? So all these numbers are in left of 3 and the product is 6, right? So this is one loop. Okay, so for this loop I am going to use time complexity of n, just O of n. Now for the right sign products I am going to start from my end. Okay, so here what is the product of all the elements which are in right of this index 2, which are in right of index 2? That is nothing but this 4 is only in the right of 2, so 4 into 1, that is nothing but 4. Okay, now what is the product of all the numbers that are in right of this one, that are right of this one? So all these numbers are in right of this one, right? 3 into 4, so I can write here 12, right? What is the product of all the numbers that are in the right of this 0 index? So all these numbers are in right of index 2, 3, 4. Okay, so what is my product? 4 into 3, 12, 12 into 2, 24. Okay, so I have written here 24. Okay, so this is one more loop. This is not nested loop. One by one I am writing the loops O of n. Okay, so this is done. After that I have to give the result. Okay, so in the result what I am going to do, I am going to perform the multiplication, simple multiplication between these two numbers, 1 into this one, this one, this one and this one. Okay, so what is 1 into 24? 1 into 24 is nothing but 24. What is 1 into 12? 1 into 12 is nothing but 12. What is 2 into 4? 2 into 4 is nothing but 8. What is 6 into 1? 6 into 1 is nothing but 6. So this is my output, right? 24, 12, 8, 6 is my output here, right? So I hope that you guys are clear. Okay, so this result array, when I'm going to do the multiplication again, I'm going to use O of n. So what is the total time complexity? Total time complexity is nothing but O of n plus n3 and is equal to O of n only. Okay, so O of n is my time complexity. Okay, so I hope that you guys are clear with this logic, right? Okay, so this is one way to solve this problem. Now let me write the code using the same story that I have explained here. Okay, I'm going to write the same things here. Okay, so now let's get started with the code. So first of all, let's calculate the length. Int n is equal to nums dot length, length, right? And I am calculating the left side products and right side products, so I have to make one array. Okay, left side products is equal to new int and give the same length, and for the right side products again perform the same thing. RSP is equal to new int n. Okay, now I have to create one result array where I have to store the result, right? Int res is equal to new int n. Okay, initially I'm starting from, for the left side products I'm taking this default value, right, is equal to 1. So can I write it like this? LSP of 0 is nothing but 1 in the starting, is equal to 1. Now run one loop. Okay, and okay, so now I have to fill the values starting from here, right? 1, 2, 6. I am starting from here. So let me start from 1, right? Int I is equal to 1, I less than n, I plus plus, right? This is done. And LSP of I, left side products that I am calculating, so I have to write like this: LSP of I minus 1 into product. Okay, so I have to into LSP of I minus 1 into nums of I minus 1. Okay, what was my last number, I minus 1. Okay, so here this LSP of I, this number is equal to my nums of I, that is 1 into my previous one, 1 into 1, right? So here 2 into 1 is 2, 3 into 2 is 6. Okay, this is how I am feeling, right? So this is done. So I have calculated the left side products. Now same way we have to calculate the right side products, but in the right side product I am feeling this value initially, this one, right? So this is at which index? N minus 1, right? N is 4, 4 minus 1, 3. Okay, add RSP, N minus 1 is equal to 1. Okay, now I need to fill the indexes from the right side, from the end. So I have to write like this: int I is equal to n minus 2, because I have to fill this index first, right? And this is n minus 1, this is n minus 2, right? So I is equal to n minus 2, and I must be greater than equal to 0, and I have to decrement the I, and after that inside that I have to just fill the values. RSP of I is nothing but RSP of I plus 1 and into nums of I plus 1. That's it, right? So this is done. Okay, so here I have calculated the right side products. Now after that I have to perform the simple multiplication, right? To perform the simple multiplication, let's run one loop for int I is equal to 0, I less than n, I plus plus. Okay, and here in the result of I is nothing but result of I is going to be nothing but our left side products of I into right side product of I, and in the end I have to just return my result. Okay, that's it. So this is going to be my result, right? This is going to be my code, return. Okay, return result. Everything is done. Now let's run the code and see if there are any mistakes with our code. Okay, so why I'm writing result here, it is res only, na, res. Okay, so this is done. Now let's try, let's see. So our solution, okay, so we are facing some issue here. I is equal to here I have told you now I'm going to start from this position, index 1. Why I'm writing 0 here? I think while explanation I have told 1 only here, but somehow I write 0. Okay, so this is done. Also now good. So all the test cases has been accepted. Now let's submit our code. So our solution is accepted, right? And the runtime is 2 milliseconds, right? So I hope that you guys are able to understand this code. Okay, and yeah, can we modify this code little bit? Can we try to modify this code a little bit? Let's try to do that. I'm going to do the same thing here. Int n is equal to nums.length, and let's not use these two arrays. Okay, and in the result array I am going to store result and initially left side product. Okay, so let's take it as like this: int left side product initially is equal to 1. Okay, int left side product is equal to 1, and here take it as int RSP right side product is equal to 1, and here I am going to run one loop for int I is equal to 0. Let's run it from 0, I less than this. Okay, and in the left side product I am not using array right now, so left side product is equal to left side product into my nums of I. Okay, nums of I, and I have to store my result here. So let's store result like this: result of I is equal to left side product. Okay, and in the right side product, int I is equal to n minus 1, I is greater than equal to 0, I minus 1, and the result of I is going to be my result of I into right side product. Okay, and my right side product is going to be right side product into nums of my I. Okay, nums of I. and in the end I have to return the result. Okay, so here int n is equal to nums dot length, int result is equal to new int n, int left side product I'm taking 1, and then I'm running one loop and I'm storing result side by side. Instead of running one more loop for the multiplication, I'm just going to do this. Okay, so this is done, right? This is done, but here I'm making one mistake. I don't need to use this. Okay, I don't need to use this loop now. Let's format the code and see. Left side product I'm taking as 1, then I'm running one loop, result I is equal to left side product, and left side product I'm doing the modification lsp into nums of I, then right side product, then I'm running one loop from the end right hand side, and then I'm updating my result I as a result of I into right side product into nums of I, and then I'm returning result. So let's run this and see if this code is accepted without additional loop. So yeah, so this all the test cases has been passed here, and let's see. Okay, so this solution is accepted as well, and now our runtime is just 1 millisecond. 100% of users with Java. Okay, it beats. Okay, so here I'm just using a 1 of 1 extra space complexity right now. Okay, because this result we need to give the result. Okay, and other than this I am just storing of 1 extra space complexity. I can make it like this, int ls int product. Okay, instead of lsp I can just modify it to product, right, replace all, and here also instead of rsp I am going to make it product. Okay, so that I'm going to use only of 1 extra space complexity. Okay, instead of n control nums dot length now. Okay, so this I'm going to make it nums dot length here, nums dot length here. Okay, this is done, this is done. Okay, I'm not going to use anything additional right now. Okay, this is done. Now let's run the code and see if anything we have missed. Okay, okay, so now again you see 1 millisecond only. So here what I did, follow-up question is that can you solve the problem in of 1 extra space complexity. Okay, so result is what we need. Okay, and other than this I am just using this additional of 1 space complexity, right? So here what I'm doing, I'm doing the same thing. Okay, let me copy this code here. I'm doing the same thing here, it's nothing different. Okay, so here this is my code. Okay, initially what is my array? My array is like this now, 1 1 2 3 and 4. This is my array, right? I hope that you guys are clear with this logic, right? You guys are clear with this, right? I'm going to perform the same thing. Okay, so this is my 0 index, this is 1 index, this is 2 index, and this is my 3 index. Okay, so initially I'm taking my product as 1, and then I'm going to fill the left side products one by one. So initially result of I is going to be my prod. So initially this result of I, this is the what I need to give the output in the end. Okay, so but right now I am updating it side by side. Okay, result of this, result of 0 is equal to 1, and then I am going to execute this product is going to calculate the left side product. Right now in this loop I am calculating the left side product, so it is nothing but 1. Then my result I becomes prod, that is this one reaches here. This is my result array, and this is my product array. Okay, product array or product number, because I'm taking it number only. Okay, so 1 reaches here, and my new product becomes 1 into this 2. Okay, so it becomes 2. Then my 2 going to reach here, and 2 into 3 is 6. 6 is going to reach here, and 6 into 4 is going to 24. Okay, so this is what's happening here in this code, specific piece of code. Okay, and again I'm going to run one more loop. Okay, so here what's the thing that here I am running one additional loop to store the result, but now right now I'm not going to do that. Okay, again I'm going to store a result and product here. Okay, but this time I'm going to start from the end. Okay, this place. Okay, so initially my result I is equal to result of I, that is this 6 into product is 1 right now, so I have filled this 6 here, and product is product 1 into nums of I is nothing but 4, so I filled 4 here. Okay, this is done. Then after that I have reached at this position, then my result I becomes result of I. What is my result of I at this position? It is nothing but 2, and what was the product last time? 4, so it becomes 8, right? And now product is equal to product into nums of I. Okay, so product, what was the product last time? Product is equal to product into nums of I. So what was the product last time? Last time product was 4, now nums of I is 3, so 4 into 3 is 12. Okay, same way here I am going to fill then 12, here comes 24, and then from here this 24, and this is going to 24. Okay, so this is going to be my output. Okay, so I'm not going to perform any additional 3 loops, just going to perform 2 loops, and side by side I am storing the result. So same thing that I am doing here. Okay, so if you guys are clear with this solution, then you can just do this one, and okay, so I hope that you guys are clear with today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.